Alright, last tan graph. Got to do a little factoring first. Y equals tan of, pull out a negative 1/2. What's left behind? Theta, baby. What else? Minus, what? Pi? Is that how math works, right? Because pi times 1/2 would be pi over 2. Double negative. Cool, cool. Alright, well, tan is an odd graph, which means that negative comes out. So really, I have y equals negative tan of 1/2 times theta minus pi. What's my period? Well, my period is my normal period, which is pi for a tan graph, divided by that coefficient of 1/2. And so I actually get 2 pi as my period. So let's go boombity boombity. Full period is 2 pi. Half period is pi. Quarter period is pi over 2. 3/4 period is 3 pi over 2. So I've got a phase shift of pi, which means I'm starting my tan graph at pi, and a tan graph starts with a 0. 2 ticks away from a tan graph, you should have asymptotes. Alright, that's kind of why we do 4 ticks for everything, because it makes all this stuff work out pretty nicely. When normally tan would start and go up like that, but our tan graph is negative, so it's going to go down first, which means I'll have a point there, and I'll work backwards, have a point there. So boom, 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 boom. So I get that as my graph, which is interesting because that, my dear friend, looks a lot like y equals cotan of theta over 2. Looks like a normal cotan with a modified period, which is equivalent to that crazy, nasty tangent graph that we just played with up above. I think that's the end.